In this video, you will be presented with a .NET in-process memory dump of a W3WP process consuming high memory. It is expected that you have already downloaded and opened the appropriate memory dump file in WinDBG, and the MEX extension matching the bitness of the memory dump process is loaded. Analyzing a memory dump in search of the reason for high memory consumption is one of the more challenging scenarios. In many cases, the reason is not discovered using a single command, rather a group of commands. Using the output of debugging commands can guide you to the root of the problem. Enter and execute the MEX list threads command. This can take a moment, so please be patient. The output of this command will not show memory consumption. It will instead show which threads are running. The running threads have a high probability of being the cause or the consumer of the data stored in memory. Choose a few of the threads based on the highest execution times, for example, thread 22 and thread 38. Change focus to each one using, for example, the ~22s command. And then execute the CLR stack 2 to see what's running on it. As you saw in thread 22, there were no assemblies on that stack which were non-Microsoft. However, on thread 38, you do see non-Microsoft code running on it. Take a note of the assembly name and keep it in mind. This is clue number 1. Memory is mostly stored on what is called the heap. Enter and execute the dump heap stat command. The output of this command shows the objects which are consuming memory for this process. Notice that there is a little bit over 11,000 system.char arrays consuming 1.9 gigabytes of memory. To drill further into what is contained in those arrays, enter and execute the dump heap method table. It's not always intuitively obvious from this point, and you will need to do some detective and investigative work. This can take some time, and it is also possible that you will not find anything of value here without a much deeper level of debugging. You do see a lot of objects with the size of 16 KB and some more with the size of 102 megabytes. Those that are 102 megabytes should stand out as a place needing attention and more investigation. You would want to perform the following on each of those objects and compare your results. The first object with 102 megabytes begins with 77. Let's dump that object. That renders information about the object containing the 102 megabytes of memory. The text next to the content is clue number 2, which may be helpful to a developer in determining where this data may be coming from and where in their code it is referenced. Next, enter the GC root of that same object. This identifies the thread ID of 46A4 that is utilizing those objects and the specific method which is using that data. The thread ID of 46A4 and the identified method are clue number 3. The probability of the C# guitar assembly, and the high memory page being the reason for the high memory is high. Look back at the output of the list threads, and you will see the thread ID of 46A4 next to the DBG ID of 38. Provide the findings from clue number 1, number 2, and number 3 to the party owning this assembly and have them investigate the code to determine the actions required to prevent it. Finally, but extremely important, is to recognize that memory dumps contain very sensitive information. Take extreme precautions and follow documented procedures for handling of these files. Remove them from all devices once they are no longer needed.